Good day, everybody. Today we're looking at the concept of fractions. Now, what are fractions? Fractions, or rather a fraction, is any value that is greater than 0 but smaller than 1. For instance, if you look at a fraction such as 1 over 2, we call this a proper fraction. And then a value such as 2 over 4 is an example of another proper fraction. 7 over 8 is another example of a proper fraction. 3 over 8 is another example of a proper fraction. Let's look at two more. 5 over 10 is another example of a proper fraction. And 20 over 40 is another example of a proper fraction. When you look at all of these fractions, you can clearly see that the numerator, which is this value here, it's smaller than the denominator, which is this value at the bottom there. Look at all of these values. They all have the same identity in terms of having a smaller numerator and a greater denominator. See, all of these numerators are smaller than the denominators. We call these, all of these kind of fractions, proper fractions. Now, let's go back to the concept of fractions. If you look at fractions, the idea of proper fractions, for instance, concept of proper fractions. If you look at proper fractions such as 1 over 2, and if you want to add such a fraction to another half, I'll illustrate this shortly. You need to look at first at the denominator. That's the first assessment that you need to consider or carry out. Look at the denominators, which are these values here. Ask yourself if they are the same. In this case, they are the same, so you don't have to worry about getting them to be the same. And then you look at the numerators. Basically, you simply, just since you did an assessment with regards to the denominator, you just simply now add the numerators. So in this case, you'll say 1 plus 1, is this one here, you get 2, and then you keep or maintain the denominator. In this case, how many times, I need to ask yourself, how many times can 2 enter into 2? 2 enters into 2 once. So you have 1 whole. In a nutshell, let's look at how this applies on this side. What this technically means if I have a half and a half. If you want to add this half and another half here, technically this is what you will do. A half plus a half, taking this half and adding this other half. This other half gives you 1 whole. Hence, this whole here, this whole value here. Okay, let's look at other properties of fractions. Now, in order for us to be able to fully understand the concept of fractions, we need to now look at other identities of fractions. For instance, if you have 2 over 4 and you want to add a fraction such as 1 over 2 or a half. Now, the first thing that you need to do is to carry out an assessment on the denominator. whenever you add fractions. Now in this case, our denominators are different. I have 4 here and I have 2 here. In this case, I need to now ensure that I get the denominator to be the same. I need to get the denominator to be the same. So now to get a denominator to be the same, we need to multiply. So I'll multiply this 2 by a value to get 4. What value can I multiply 2 by to give me 4? I'll multiply, or need to multiply this by 2. Whatever I do at the bottom, I'll have to do on the top as well. Now, let's write the fractions as they are again. So we have 2 over 4 plus 2 times 1. In this case, this is 2 times 1, I get 2. 2 times 2, I get 4. Now, denominators are the same. Now, once the denominators are the same, then you can start looking at adding the numerators only. So let's go ahead and add our numerators. 2 plus 2 gives us 4, and then maintain 4. Whenever add the denominators whenever you add fractions. So how many times can 4 enter into 4? It enters once. So we still have 1 whole. But now, the question is, what most students actually ask is, how do you get, or rather how do you illustrate this kind of example in terms of fractions? Okay, this is quite simple. Let's clear the screen. We had 2 over 4 plus a half. Now, notice here, to get these denominators to be the same, I had to multiply by 2, I had to multiply by 2, and I had 2 over 4 rather, and then adding that, I had 2 over 4. Now, notice what I have to do here. Okay, let's try and illustrate this concept further. So what I have here, look at this value here, it's 2 over 4. In other words, this denominator tells us how many equal parts is this pi. I'll call this a pi. I'll call this a pi. How many equal parts is this pi divided into? Now in our case, this pi is divided into 4 equal parts. So I'll count them. It's 1, 2, 3, 4. That's what the denominator tells us, this value here. Okay. I'm not confused. And then this numerator tells us how many equal parts are used, or rather shaded in this pi, or should be shaded in the pi. In this case, I need to shade from these 4 equal parts. I'll only shade 2. Yes, I have 1, 2. Okay. Remember now, in this case, I was adding my fraction. In this case, I was adding my fraction. So use a different color. In this case, I was adding my fraction. Is my addition sign there. I was asked to add another half. Okay, let's use another pi rather. If I take, remember now, this 2 reminds us of how many equal parts is this pi divided into. I'll explain further the concept of equal. Very, very important when it comes to fractions. This 2 here, right here, denotes how many equal parts is this whole divided into. So in other words, this whole is divided into two equal parts. So now this numerator here denotes how many equal parts are used. How many equal parts are used or rather shaded in this part of this pie. This is now the second part of the pie that we're talking about. So how many equal parts are shaded? Only one, or rather half of it. B. So now, essentially, if you look at this portion here, right here, and this portion here, I'm using the different color, this portion here, you can clearly see that these portions, this portion and this portion, are actually a half, if I may have to denote it on the side. If I take that portion, this one here, and this portion here, I'll draw it facing the other part A. If I may have to flip this part here to look like that, this part here. And if I may have to bring these two parts together, or other parts are actually essentially fractions. If I may have to bring these parts together, I'll put the addition sign. This technically gives me a whole fraction, or rather a whole value, or a whole pi. So that is the one whole. And then this part here is, we look at this part again. This part here is this bit part or portion. And then this part here, I'm going to use a yellow color. This part here is this part here. Hence, one whole. Okay. Thank you for the first introductory part of fractions. We'll look at another component of fractions shortly.